The molecules that we've been looking at so far have had atoms that the carbons are all connected in a straight line. Now, when I say straight line, they do kind of zigzag if you look at the shape of the molecule themselves, but we can go from one carbon to the next. Everything is connected in one continuous chain. So this, because it has 1, 2, 3, 4, 5 carbon atoms, would be called pentane. All of those carbon-carbon bonds are single bonds. But what if I have a branch coming off of one of these carbons? So if I take off that hydrogen and replace it with a carbon chain here, now I have 1, 2, 3, 4, 5, 6, 7 carbon atoms. But I wouldn't call this heptane because that would imply that all 7 carbon atoms are in a straight line. But we can see here, instead of just going one after another, this carbon is bonded to another group of carbons. So we have a branch coming off of here. So if you have all of them in one continuous chain, it's a straight chain alkane, and you just count up the number of carbons and name it like that. But if it's got a carbon that has a bond to 3 other carbons, then we have a branch, and we have to name that a little bit differently. Now, the first thing that we have to do is find the longest chain, because molecules aren't just sitting stationary. And I can see that I have a chain of 5 here, but if I rotate this a little bit, maybe a little bit more clearly, you can see I have 1, 2, 3, 4, 5, 6 in a chain. Well, 6 is greater than 5. So when I go to name a molecule, there can only be one correct name for it. So the first thing that we have to do is to find that longest chain, keeping in mind that we can bend and curve as long as we're following along carbon-carbon bonds. Once I get to here, I could either go down or I could go over here, and I want to find the longest chain. Also, when we're going to number the carbons, because we're going to have to tell where that branch is coming off, just like we would for where the double or triple bond is in an alkene or an alkyne, we need to remember that, again, this thing's flipping around. There is no left side and right side. So once I've found the longest chain, I can count from both directions my carbon atoms, and I'm always going to use the smallest number. So for example, 1, 2, 3. Here I've got that carbon branch coming off of 3, 1, 2, 3, 4. There it's coming off of carbon number 4. 3 is smaller than 4, so I'm going to number from the side that's closest to where that branch occurs. So essentially, even though our diagrams might look like we've got nice straight lines and right angles, we really don't. It is just a jumble of atoms at all sorts of weird angles that's constantly moving around. So there is no, we have to go in a straight line horizontally across the page. We can twist and bend and curve and follow chains that way, because they don't look as straight as we actually draw them quite often. The other thing that I want to talk quickly about is how we write the hydrocarbons. There are lots of different methods to write organic molecules. The ones that I've done so far, I've drawn out the carbons and I've drawn out all of the bonds to hydrogen as well. But when we get really big molecules, this can end up becoming a little bit more cluttered to read with all of the hydrogens there. So another way that we can write this is, instead of writing the carbon with the bonds and the 3 hydrogens, we can take this piece and write it as CH3. This is forming what's called a condensed structural formula. It's pointing out where all the carbons are. It's still telling us how many hydrogens, but it's not drawing all of them in with their bonds. So that would be CH3, single bonded to, this is a carbon with 2 hydrogens, bonded to a carbon with 3 hydrogens. Really, all you need to focus on is the carbons. The hydrogens are just there because they are in the molecule, but we're only focusing in on the carbon atoms when it comes to naming them. There are ways of condensing this even further, but this is as condensed as we are going to get in this course. So if you see the CH3 or a CH2 or something like that, that just means those 3 hydrogens are actually bonded off of that carbon like this. It just kind of unclutters the image for us a little bit. Here we have a branched alkene. Branched alkenes or alkynes would be named just the same as a branched alkane and indicating where that double or triple bond is, just like we did earlier. Now, I did leave the hydrogens off here just to kind of keep us from getting confused to unclutter the picture for us. Longest chain is going to be 4, whether I go 4 across or across and down, it really doesn't matter. So just for fun, I'm going to go the across and down. Again, we're going to number from both sides. 1, 2, 3, 4. And 1, 2, 3, 4. Now the two things that I'm going to need to locate are the branch and the double bond. So again, we want to look at the numbers. If I use the red numbering, my double bond starts at carbon 2 and my branch is coming off of carbon number 3. If I use my green numbers, the branch is coming off of carbon number 2 and the double bond is starting at carbon number 2. So we're going to want to use the green numbers because those are going to give us smaller numbers than if we used the red ones. So again, I need to name the branches first. There's 1 carbon in this branch. The prefix for 1 carbon is meth, so this is a methyl group. And it's coming off of carbon number 2. So 2-methyl dash. So again, numbers are separated from words by dashes. So dash coming off carbon number 2 is my double bond, which is going to make this be an alkene ending in ene. And there are 4 carbons in that longest chain. The prefix for 4 carbons is bute. So 2-butene. So coming off of carbon 2, there is a 1 carbon chain. Coming off of carbon 2, there is a double bond, and there's a total of 4 carbons in the longest chain.